Hi guys, and thanks for watching again. Today I will be demonstrating on how to connect a 7 or 8 segment LED display to the Raspberry Pi without using 7 or 8 GPIO pins. This setup only requires three GPIO pins and can be extended with another 3 of these shift registers without the need for more GPIO pins. This setup is very easy, and any shift register starting with 7.4 ending with 595 will do fine. So let me start by showing you that it actually works. So I'll go to my computer and then let's see, digit 1, there we go, 5 and a dot works also. 8, so almost every LED is lit right now, so turning it off. And again, this is the Raspberry Pi Zero, but any Raspberry Pi will do fine. So these are the 3 GPIO pins I used, and this is just the power supply. And see if I can get this circuit I made in camera. There we go. It's little messy, as you can see, and I didn't use any resistor but I should have. This power supply is only 3.3 volts. I used it straight from the Raspberry Pi, and these LEDs can handle that just fine. But normally when using a 5-volt power supply or something like that, every LED requires its own resistor, of course. Yeah, because this setup is not very clear right now, I made some drawings. Get this out of the way. This is the shift register over there in this exact position, and the power supply is connected to 2 pins, 2 positives and 2 negatives over here, and this shift register will work on anything between 2 and 7 volts. So it's connected to the 3.3 volts of the Raspberry Pi Zero, which works just fine. So, and this is how I connected all of the 8 LEDs on this segment display over here. This is pin 1, which matches with this one over here, 2, 3, 4, 5 in the middle, 6, 7, 8, and that's how it's connected. Every pin, of course, is the positive and the negative of this LED display is in the middle, and this is how this looks on the back of this display. Negatives are in the middle. I just connected one of them because they're interconnected. All these are positive, 1, 2, 3, 4, 5, 6, 7, 8, like this. And these are just the 3 GPIO pins I used. I connected them to pin 11, 12 and 13 board number pins, not the GPIO pins. Of course, GPIO pin 17 is pin number 11, pin number 12 is GPIO port 18, and 13 is 27. So that's all there is for about how to connect it. And of course, when you want to another of such a display connected, you can just add another shift register, connect GPIO pin 12 and 13, just connect them to the other shift register. Do not connect this one, number 11, straight to the other shift register, but connect this pin from the first shift register over to the other one on that one. So you can daisy chain them all together up to 4 of these shift registers. So yeah, I made a little Python script which just displays all these numbers, which you can call from any other script or anything. Of course, you can also do it in C++ or anything, but my Python is just a little bit, understanding of Python is just a little bit better than my C++ understanding, so that's what I did. And Wiring Pi is one of those great libraries which works with Python, and it has already a support for the shift register, the 595, built in. So Let me start by switching to my PC screen so you can see what software I wrote. So this is the software I wrote. It's a big name for such a small Python script, but it is software. Yeah, let's start at the top. This Python script, I import the time, sys and wiring pi libraries. And here we set up the wiring pi and continue with the shift register 595 setup. It's one of the best things wiring pi has on board, because this made it a lot easier for me, so I didn't have to look into the data sheets for the shift register. It was all done for me. So this is the base number we're going to use. See it over here already. 40 pins. This is the number of pins connected in total to the Raspberry Pi, and these are the GPIO pins connected. So I made a little dictionary, as they call it in Python, with nothing, 0, 1, and all the way to 9 and a dot, which correspond with all arrays, and then this displaying of just showing which LED to light for each digit. So the 1 only requires 2 LEDs to light, so that's how it works. And this is, then we continue. When the dictionary is finally defined, I do a simple check. If the number of arguments given to the command line tool is lower than 2, the 1 is always the name of the script itself, and 2 is the extra argument. So if I do not enter an argument, the script assumes that you want to turn off all the LEDs, so that's what I do. Just a simple for loop, range from 0 8 times, so 0 to 7, and then use the wiring pi digital write, use the base number again, including the integer I was looping before, so from 0 all the way to 7, so 100, 101, 2, 3, 4, 5, 6, 7, and set the state to off. And that's all what the shift register does. It turns off all the 8 LEDs. And here we go, exit the Python script, because we do not require the extra loop below. Of course, I could have written an else over here, but that's just me. I do not like large indents of all indenting trees and if else anything. I just like to keep it simple. So we're done, exit the script and do what we need to do any further. So here we do the same loop again from 0 to 7, and if one of these 0 to 7 digits is in the array we found, so the numbers dictionary over here is the argument. So when the argument I give to this script is 5, then this thing over here just contains this array of 1, 2, 4, 5 and 6. So if 0 is, well, we start with 0, is in this array, it will light. If it is not, it will turn off. So then this loop continues, and then it's 1, and yeah, 1 is in this array, and then it will light all the way to 7, and that's basically all it does. Now, of course, I can connect anything or use any script I want to light this display, anything I can think of, but yeah, that's how I connected it to a Raspberry Pi. So thanks for watching.